This video is going to be very interesting because in this video I will walk you through the simple linear regression code in Jupyter Notebook. Alright, so I will walk you through all of these steps and phases of simple linear regression. So basically in simple linear regression, we predict our dependent variable y using only single independent variable, sorry. Alright, so we use only one independent variable in order to predict our dependent variable. So I think it's clear. So I will go through the code. So let's start. So basically we can see here that here I imported our necessary modules. Here then I looked at our data frame head, and before that I read into our data set, and here we can see that we have many columns, and we will pick some columns like CO2 emission, which has an impact on our dependent variable. All right, so we will look one by one, like which column has an impact on our dependent variable, and in this case we have a CO2 emission, so we are going to predict CO2 emissions, all right, for the upcoming cars. So we have this kind of data set for now. So we just uh, so by describing our data frame we can get our information. So it's like we may get a feel of what about data set is and what kind of data set. Like we can see that we have equal number of counts in each column. We have standard deviation. Here we have very low standard deviation. It's mean that the values in a data set is closer to its mean. And sometimes we have larger standard deviation. We have minimum value here is 2014, and whatever. This is the information about our data frame. So let's go ahead, and we can also do info on our data frame. We can get like what are the data types of our columns. We can see that we have 1 2 3 4 5, we have almost 6 to 7 numeric columns, and other than that we have string columns, and we don't have any null values. So this data is already clean in order to process into our machine learning model. So this data is already clean, so we don't need to do any data pre-processing or something like that steps. All right, so let's grab our 4 columns: engine size, cylinders. So I was interested in these columns, so that's why I selected these. And we can see here by looking at our head of our the data frame, and now we have only 4 columns. All right, so we have engine size, cylinders, fuel consumption, CO2 emissions. So we will actually one by one look at our impact on CO2 emission column for each of our independent columns. All right, so here I drew histograms. So we can see that we have cylinders, engine size, and we can see that we have solid numeric values, int values, not float values for our cylinders. And it makes sense because we can't like say that there are 2.5 cylinders. It doesn't make sense, right? So we have engine size, you can see maybe between 2 to 4. We have most of engines here. We for fuel consumption we have maybe from 7 to 15, and for CO2 emission we have 200 to 300. Okay, so it basically gave us a general idea about how our data is looking. Okay, so basically, okay, good. So now let's move on to the next one. So first of all, we will look at our linear relationship between our fuel consumption column and CO2 emission column. All right, so here we can see that I drew a scatter plot here for the fuel consumption against CO2 emission column. All right, so on Y we have emission, and on X we have fuel consumption So basically we can see that we have some sort of linear relation, but it's not that perfect, right? Maybe we can see that it's go in this direction, and this is one is going to in this direction, and so on. So it's okay. So now let's check with other columns. Let's now check with engine size. So we can see here that it's more accurate. I think it's more linear. So basically, when we will increase in engine size, it will lead to increase in emissions too. So basically, engine size has more impact on our CO2 emission column. Basically, this one is perfect than this one. So now let's move on to the next one here. So now let's check now cylinders. We can see that we have some sort of linear, but it's not cool enough. I think the engine size is the perfect one. All right, so we can see that we have like we can have amazing line between these. Basically, we for the simple linear regression we need to make a line. All right. So we need to find a perfect line. So in order to find that, basically we have a formula. Let me show you. Y is equal to, we have theta. This is a basically intercept. All right. And this is theta 0 basically. I can't write here, but however I can show you. And we have a theta 1 into x, and here x is a independent variable. All right, and y is a dependent variable, and x is an independent variable. All right, so and this theta 0 and theta 1 are the parameters of our fit line, and where theta 0 is basically our intercept of our line, and theta 1 is our slope or gradient of our line. All right, so basically we need to find these two parameters, and then we will put our x here, and x in this case we will have an engine size. All right, so we will find put simply put after finding these two parameters, we will simply put our engine size value in this equation, and we will find a new CO2 emission. All right, so it's simple as that. So now let's revert it. Okay, so now it's time. So basically we now make decision that we are now going with engine size column. All right, so first of all, let's split our data set into train test data. So I'm going to take 80% train data set. All right, so I'm taking 80% train data set and 20% test data set. So I do a scatter map again here, so we can see that we can have a amazing line to our data set fit. And okay, so now let's move on to the training part. All right, so here I imported the linear model from our scikit-learn library, scikit-learn, and what I am doing is I am initiating the estimator here, linear regression. All right, this is the estimator, and basically I am putting the values of engine size. I am taking the engine size as our training x data, and then I am taking our CO2 emissions. Basically this is what which we will find. All right, this is our target variable. So I'm basically passing taking this as a training y data. All right, and here on I'm fitting our data. So basically this is the training step. Here I'm basically training the model, and I'm giving its train x data, and corresponding to that I'm telling, for example, if the for example engine size is for 2, then the co-emission for this will be 400. So I'm training the data in the way. All right, in this way. So here we will done with our training our data set, sorry, model, and then we can find our coefficients and intercept. So we can see that it finded the coefficient 38 point and whatever, and it finded the intercept for our fit line, and this is the intercept. So we can get something like this. All right, so now let's let's map a line into our this scatter map. So it's very simple. Basically we will just write our scatter function here, and we will pass as just we did here. All right, but here we are doing extra step plotting. All right, so here I pass the training x data set, and on y-axis basically I just told you the formula. So basically this is the formula. So what I am doing here is I am basically adding a intercept and multiplying the training data into our coefficient. All right, so this is just like this. So basically if we have y, and we have theta 0, which is the intercept, plus theta 1, and here we have x1. All right, so theta 1 is here is a intercept. All right, and here we are basically adding intercept to this term on the right side. So here you can see that we are adding intercept, and here we can see that we have a multiplication between theta 1 and x1. So we are multiplying by coefficient with the training x our data set. All right, so that's how we are plotting our line. So we can see that we have a fit line to our data set. All right, so we have a fit line. So that's amazing. So now let's move on to the next step here. And so now basically after fitting our line, so basically we need to check the errors. All right, so there are many methods we can see. We can have mean absolute error, mean squared error, residual sum of squares error, R2 score error. So these are the errors, and how we can calculate errors, it's important to know. All right, So basically, we can see that this is, for example, a point here, and we need to see that how much is the distance between this point to this line, all right? And we need to do this for all of the data points. And don't worry, the model is already doing these things for us, all right? So basically, what it's doing is it's calculating the distance between these two, and then it's basically subtracting this from our predictions, which we make on our testing data set. All right. So for now, we just fitted our data set and trained, and then just we plotted a line. All right. For now we just plotted a line, but now we didn't test this thing. All right. So now basically we are going to test, and here I imported R2 score, and here I am taking a test X data and test Y data. This is a data which we actually created here. All right. So here I'm getting these two data sets, and then what I'm doing is I'm using a predict function on our regression estimator model, and here basically we are predicting. So basically I'm passing a text X data set and test Y. So basically where we will use test Y, we will use this to find our errors. All right. So basically now in test Y underscore. In test Y underscore, basically we have our predictions from our model, and we know what we will do. We will basically subtract our test Y from these predictions. All right. So first of all, let's calculate our mean absolute error. So we can see that mean absolute error. We need I'm using np.absolute function, and what I'm doing, I'm subtracting our predictions. I'm subtracting actual values from our predictions, all right, which is made from our model, and then I am taking the absolute of these values, and then I'm taking the mean. And residual sum of errors, I did something like this, all right. And then for R2 score, basically the maximum value for R2 score is, let me mention here, the 1. So the value, if the value is nearer to 1, so it's mean the performance of the model is very amazing. Good. All right. And so now let's move on to the next step here. And what I'm going to do here is I'm basically now going to train a data set against fuel consumption column. All right. So I took train next data set, then test Y, and then I again initiated our linear regression model, and then I trained this model again, and then after training this again, I did predictions. All right. I did predictions from our testing data set. Then we calculated these errors again. So we can see that this is how we performed some sort of simple linear regression. But here we can see here that we can see for now I separated these values as these, but don't worry, in future I will use separate functions from the scikit-learn. But for now, in order to educate you how we can do simple linear regression, so it was very simple. All right, and there is nothing more. But I would suggest you to go through another videos on my YouTube channel or maybe on some other channel. So I hope you like this video. So just subscribe if you want to see more videos from my channel. Thank you so much. Bye bye.